Okay, so we were studying in the last session about some learning algorithms. So we saw basically decision trees, rule-based system, nearest neighbor classifier, Bayes classifier, etc. So today we will do the important classification using neural networks. So neural networks is also the precursor for the deep learning algorithms, which we will study a little later. So, if we come to neural networks, it's a computational method which is inspired by the brain and the nervous system. So, you have the brain which consists of neurons, an interconnection of neurons, and then you have the nervous system which goes throughout the body, and this method actually is inspired by that. So there are some definitions regarding this. A computing system made up of a number of simple, highly interconnected processing elements which process information by the dynamic state response to external input. Okay, so what is a neural network? It's an artificial representation of the human brain. So we'll see what are the parallels between the human brain and the neural network. Okay, so we could talk of it as the biological neural network and the artificial neural network. So you can call both of them as neural networks. So a neural network, if you see, it has the word network, which means that it's a graph. So basically you have nodes and you have edges or the links between nodes, and it's mainly directional edges that we have between nodes. So you have something called input nodes, and to the input nodes will be giving the input, and you have the output nodes, and in the output nodes we'll be getting the output of what we want. And all the other nodes or layers, as you call them, which are there in the network, are the hidden layers which are there in between. Okay, so it's a network of simple processing elements which can exhibit quite complex global behavior. Okay, so let us see how actually you're doing this. So why would you use a neural network? Okay, the conventional computers are good for fast arithmetic and does what programmer programs. The neural network system help where we cannot formulate an algebraic solution. So mainly we'll be using it to it will be something like a black box, basically, the neural network. So you're going to have something like a black box. So you are giving the input into this black box, and what you are getting out of the black box is the output that you want. So what you are going to do is you are going to change the parameters inside this black box, so that for every input that you give, you get the appropriate output. So the thing that is changed here, for example, if we have two nodes in your neural network, you have a link between them. This will have some weight W. So if this is I and this is J, you have Wij, that is the weight between the node I and the node J. So it's the weights of these links that you are going to change in a neural network. So basically when you talk about training the neural network, it means updating the weights in the neural network till they give you the appropriate output for a particular input. So what are some of the advantages we can see of neural network? You have a simple processing elements with a high degree of interconnection. simple scalar messages and adaptive interaction between elements. Okay. They are based on the architecture of the biological brain. So let us see first what the human brain is like. Okay, it has millions of neurons. So the cells that you have are called the neurons, and these cells are all interconnected with each other. So signals are received by the neurons through a junction called the synapse. Okay, so suppose I have one neuron like this. Okay, and you have another neuron in the brain. This is the nucleus of the neuron. So some output which you are getting from these two may be connected like this, and this is known as your synapse. So you may be getting the input going into this through some link which is known as the dendrite basically, and this is called the axon. So what happens is that the information from this cell to this cell is passed on through the synapse basically, okay, through the dendrites basically. So this one actually will fire if the signal is above a certain threshold, otherwise it doesn't fire. Only if it fires you will find the signal going from one neuron to the next neuron through the synapse basically. So this is how a neuron actually looks. So we can see that the neuron has a nucleus over here, okay, and then we have these hair-like structures which are found, okay, and you have one long tube type of thing here which again goes off into hair-like structures. So these are what are called the dendrites. Okay, so the dendrites are from where you receive information from another neuron basically. So this is the cell body. Okay, you have all these. This is called a myelin sheath, etc. Right. So basic thing is there's an axon which transfers the information from here to another cell. So you have all these other things which we needn't worry about as of now, right? So what happens is these are some of the important aspects of the biological neuron. You have the soma or the cell body. So that is this is the soma, the cell body, the axon which goes out here, okay. It's a nerve fiber attached to the soma which can serve as a final output channel of the neuron. And then you have the dendrites, represent a highly branching tree of fibers, okay. And then you have the synapse. So these are the synapses that you are finding. So the synapses will be between the dendrite of one neuron and the axon of another neuron. So the information comes through the axon of another neuron and comes into this neuron through the synapse and through the dendrite basically. So that's the important part of this, okay. So we have seen all these things, like you can see again the same information is there in this, right. There's also information about other things like myelin sheath, node of Ranvier, etc. But we will not go into those because they do not really, we will go into the technical, the artificial neuron part of it, right. So how is the information flow? It's through the axon, okay, and the output is going to another neuron from here, okay. So dendrites receive activation from other neurons. Soma processes the incoming activations and converts them into output activations. And axons act as a transmission line to send the activation to other neuron. Synapses is the junction which allows the signal transmission. And this is done by diffusion of chemicals which is called neurotransmitters basically. So let us now get into the neural network, what is happening in the neural network. So the first we will talk about the feed forward type of neural network. So basically it maps a particular input to a particular output. Okay, so at the beginning a particular input may not be giving you the correct output. So what you are doing is you are going to adapt the network so that for the particular input we want it gives a particular output. So what you have is the neurons are the, or we can just call them the nodes, right? So you have nodes which are connected to each other by weighted links, okay? So the input to a node depends on the aggregate of all the inputs. So we have, if we have one node like this, and these are all the inputs coming to this node, right? Then the aggregation of these inputs, okay, so the sigma of the input will come here to this node, and then you are taking the output from this node which is a function of this sigma input. So we will say what that function is basically, okay. So obviously the output of your complete network, okay, and then this output will go to another node, right, in this way, right. So the overall output of your network depends on the weights of your network, okay. So if you are not getting the correct output for a particular input, then you need to update the weights so that you get the correct output for the input that you are giving. So this is what is known as the training of the neural network. So it's the training of the weights basically, okay. So the output of the ANN depends on the input and the weights in the network, okay. And of course it also depends on the configuration of your network that you are using, okay. The training of ANN consists of making the network give the correct output for every input. Training is done by updating the weights in the network basically, okay. So learning in ANN is nothing but making appropriate changes to the weights basically. So this is the neuron that we have, okay. So if you have a neuron like this, you are having these inputs, and these inputs are first aggregated, and once it's aggregated you find G of the input. In other words, it's a function, what is called the activation function, and then you get the output, and that output is sent out to the other links, okay. So it receives n inputs, multiplies each input by its weight, right. So what you have is, this will be equal to sigma I of AI WJI, okay, and so G of this will be your A of I, which you are getting out from here. So if you have say x1, x2, x3, x4 which is coming in here, you take it as W1 times x1 plus W2 times x2 plus W3 times x3 plus W4 times x4, okay, and the output that you are getting here will be a function of that, which depends on the activation function which you are going to use. So we will see what are all the possible activation functions that we can have, okay. So these are the activation functions. The first activation function is called the threshold or sign function. Okay, so what you have is that uh, if the input that you have is uh, if your x that you are getting, the x that you are putting into your activation function, if it is greater than or equal to 0, you will get an output of 1, otherwise you get an output of 0. So the output you have is only 0 or 1. Okay, so whatever may be your sigma, the aggregate that you have, the output of your neuron will be just 0 or 1. The second one is what is called the sigmoid function. Okay, so you take the value of x and you do use this function. So sigmoid of an x will be 1 over 1 plus e to the power of minus x. So what you are going to get here is a curve like this, right? So this curve is such that it actually gives you a continuous value between 0 and 1 as your output, depending on the value of x that we have. Okay, so what we have on the x-axis here is x, okay, and this is your sigmoid of x, what's on the y-axis. So this is another activation function that you have, okay. So this is how you have the neuron, okay. So I is equal to x transpose into w, okay, which will be x1 w1 plus x2 w2 etc. Okay. So w are the weights that you have, okay. Then y will be a function of this minus phi of k, which is the threshold that we have here, okay. So you have a threshold value which is put into this, okay. So what is the threshold that you have? Okay, so what you are using, q is a threshold which is subtracted from it, or in some cases you can have the threshold to be equal to 0 also, right. So for example, if we take this example over here, okay, we have x transpose into w. So your x transpose will be 1, 2, 3, 1, 2, 5 and 8, right. So when you transpose it, it will come like this, and w will be the weights here, plus 1 minus 1 2. So if we take this product, you are going to get 14, right, which is 1 into 1 plus 2 into 1 plus 5 minus 5 into 1 plus 8 into 2. So you get 14, and the activation function, if you are using a binary activation function, if the value is greater than 0, then your output will be 1. So that is what you are getting over here. Or you could be using the sigmoid activation function. So it will be 1 over 1 plus e to the power of minus 14. Okay. So there are some other types of neural networks like the recurrent network. So what we are going to see is the feed forward network, but we'll just talk about what are the other types of networks which are there. You have the Hopfield network, okay. So these use bidirectional connections, whereas the feed forward network has the connection only in a one direction, okay. So you have directed links and you have symmetrical weights, and all the units are both input and output units. The activation function is the sign function, okay. Then you have the Boltzmann machine, which use symmetrical weights but include units that are neither input nor output units. They use a stochastic activation function such that the probability of output being 1 is some function of the total weighted input. So let us look at some more activation functions. So we saw this, right. So here you have a threshold value t, and you are saying that if your output is greater than or equal to t, then it's 1, otherwise it is 0 basically, okay. And here this is a sine function where it's not 0 but it is plus 1 or minus 1. Sigmoidal we already saw, right? So you are getting a continuous value between 0 and 1. It could be any value between 0 and 1. Okay, so you can see the parallel between your neural network and the human nervous system that we have. So the neuron that you have here is something like the node that we have over here, and you have the input coming into the node here. Similarly, you have the input coming in through the dendrites into this, right? And you have the output coming out through the axon and through the synapse it's going. So that is where you have the threshold function, okay? And if it only goes above a certain threshold, only then the signal is transmitted to the next neuron. So you can see the parallel between the neuron and the node over here. So you have the output here, which is what goes down in the axon basically. Okay, so this is the synapse that we have. So the synapse is something like saying it goes from one neuron to the next neuron if it's above a certain threshold basically. Okay, now let us see the comparison between the computer and the human brain, okay, because that will tell you how your neural network is going to basically work, right? So if we take the human brain, the speed is 10 to the power of minus 3 cycles per second, right? But if we take the computer, it's 10 to the power of minus 8, which means that the computer is much faster than the speed of the human brain. But the computing units that you have are 10 to the power of 10 to the power of 11, and you may have one CPU here. So we can see that the human brain is massively parallel, okay? But if we take the computer nowadays, okay, where you have so many CPUs combined together, etc., you find that it is coming very close to what the human brain has, okay? Though at the beginning it was something like this, it was serial or it was limited parallelism, but now it's actually also becoming massively parallel. So one important thing to note here is that since it is massively parallel, there is graceful degradation. So even if you find that some part of your brain is not working sometime, or there is some damage to some neurons, etc., it will continue to work, right, because it's massively parallel. And the degradation in the performance of the brain will be very slowly deteriorating, right? So you find that even if there's some damage, it continues to work basically. So that's the important aspect of your human brain. So these are some of the types of neural networks. What we will see basically is the perceptron, which is the simplest neural network, and the multi-layer perceptron. So these are the two that we are going to basically see over here. Okay, we will not touch the others, even though they are some of the neural networks which are basically available. Okay, so let us look at what the perceptron does. So the perceptron basically has only an input layer and a output layer. Okay, so the input layer has the input which is given to it, and you have the output layer from which the output is got, and you have the interconnection between the input layer and the output layer. So you find every unit in the input layer is connected to every unit in the output layer, or every node in the output layer, but the nodes in the same layer are not connected to each other. Okay, they are only connected to the nodes in the next layer. Okay, so you find that x1 is connected to all y1 to ym, and x2 is connected to y1 to ym, xd is connected to y1 to ym. So this is what is called the feed forward network or the perceptron. Okay. So this is the simplest neural network that we can basically have. Okay. So what happens here if we have input x1 to xn, right, and your input layer, you will have w1, w2. You have this, so you have these weights, the weights between your input and the output. So this will be W11, W12, W21, okay, W22, W23, etc. Okay, so these are all the weights that you can basically have. Okay, so the input to your to the output I, okay, will be equal to W1I into x1 plus W2I into x1, etc., WDI into xd, and the output you get after the activation. So f of AI gives you your output. Okay, and what happens is you are going to give a certain input and you are expecting a certain output from this. So suppose you don't get the output that you are looking for, then you have an error, right? So that error is taken and that error is used to update these weights. Okay, so when it updates these weights, it's supposed to give the output according to the output that we want. Okay, so that is how this is basically done. So this is how the updation is carried out. So how is the updation done? Wji is equal to Wji plus alpha into xj into oi. Okay, so this is how you change the weight. Okay, so the weight is actually changed by a small amount. Alpha is called the learning factor, which will be some small value between 0 and 1 basically. Okay. So now if we look at this value over here, right, um, what you have is something like a linear function. Okay, so what happens is that if we have something which is linearly separated, okay, so for example, if we have say this value having a value of 0, this value having a 0, and this value having a 0, and this having 1, then it can be separated by a linear separator like this, right? And if this is 1, okay, you could have a linear separator which goes like this, right? So it can be separated by linear separator. But if we look at the exclusive OR function, the exclusive OR function is such that this gives a value of 1, this will give a value of 0, this gives a value of 1, and this gives a value of 0. So we cannot get a linear separator between these values. So when you don't have a linear separator, then what you need is that you need a non-linear separator. Okay. So this would be like a line if you take a linear separator in the 2-dimensional case. In the 3-dimensional case, it will be like a curve. Maybe you'll have something like a plus bx plus cx squared. or something like that, right? Instead of something like ax plus b, like we have in this case, basically, okay. So let's see how we solve this problem. So we'll do that by going into multi-layer perceptron in the next session.